This is going to be video number 1 for the 2011 Form B test. We'll do question number 1. So we've got a can with it's gathering rain. It starts out empty, and then the rate of change of the height is given by S prime. So part A says, according to the model, what is the height of the water in the can at the end? So this is the change. I want to know where we end up. So I start with how much I have at the beginning, and that would be 0 plus, and I need to integrate the change. So from 0 to 60 of S prime of t dt. And that should give me my answer. So I've already typed it in my calculator, so we're going to math 9 y1 comma x comma 0 comma 60, and I get 171.813. Alright, so let's think about that. It's a pretty big number, although I guess it is over 60 days. So the rate is given by this. According to the model, what is the height of the water? So assuming this rate is sometimes positive, sometimes negative, then it's going to go up, it's going to go down. We're going to add up all those changes, and supposedly we're ending up here, which would be millimeters. Okay, millimeters, that's not too bad. So this would be 171 millimeters. Alright. Part B. According to the model, what is the average rate of change? So when you hear that phrase, okay, this phrase right here, something should pop into your head, and that would be algebra 1 slope. And so we're thinking like, you know, y minus y over x minus x. Okay? Except, now it says what is the average rate of change of the height of the water. So we would think this if the equation we had was the height. But the equation we have is not the height, it is the rate of change of the height. So now the question is saying, what is the average rate of change? And we're looking at rates of change. So this becomes now an average value question. And so now you should be thinking in terms of adding up from A to B and then dividing by 1 over B minus A. Because this is the rates of change, so we're adding them up. So part B should be 1 over 60 from 0 to 60 of S prime of t dt. Let's check the question, make sure we're doing it right. What's the rate of change of the water over 60 periods? Show the computations that lead to your answer. Indicate units of measure. So here are the computations that are going to lead to my answer. I'm still going to let the calculator do all the work. And so really it's the last question we just did. So that's going to be, alright, it's the same integral. So we get 171.813 over 60. So I should get 2.8635. And what is it that we found? Well, we've added up all of these, or we could just do it this way. We've found the number of millimeters, and we divided by the number of days. Part C. Okay, the first time I read through this one, I missed a very important point, and the only reason I caught it is because I went back and looked at the question, and I realized that they stressed this 10 millimeters, and I kind of wondered why. I started thinking about it, and I realized that this is talking about the height of the can, this S prime of t, but this question is talking about the volume of water. So, at what rate is the volume of water in the can changing? So then I started thinking about how to do that. So the volume of the water in the can is going to be pi r squared h. The radius of the can is 10, it doesn't change. So the volume is equal to pi times 100, so 100 pi, h. Alright, so now what do they want to know? They want to know what is the rate at which the volume is changing with respect to time. So that means I need to find dv dt. When I do that, I only have one variable in my problem, h, but I'm taking the derivative with respect to time. So that means I'm going to get 100 pi dh dt. And I'm going to evaluate this now at time equals 7. So what do I need to know? That's 100, that's pi. I need to know what dh dt is at 7. Well, dh dt has another name. It's s prime. So what I really have is 100 pi s prime of t. Evaluate at 7. So now I need to find s prime and plug in 7. I already have that in my calculator, so I'm just going to go to table. I'll type in 7 for x, and I get 100 pi times 1.9169. So that's going to be 100, well, let's not be stupid here. So that's going to be an answer of 191.69 pi. And might as well give them a non-pi answer. So 1.9169 times pi times 100. 602.211. .21189. And then what are we talking about here? This is the rate of change of the volume in millimeters, so millimeters cubed per day. Alright, there's our answer. And part D. Alright, this one looks long. Okay, so same 60 days, we had another location, another can. The height of the water is modeled by, so first let's notice that the height is modeled by m of t, and that's what we have. Whereas up here, the height was modeled by s, and they gave us s prime of t. So we don't have the same information. The height is millimeters times days, so same stuff. And they've defined dt as the rate of change of m minus the rate of change of s. Apply the intermediate value theorem, which is the one that says if you know you have a value down here and then later you have a value up here, that we have to hit all the y values in between. So it says apply the intermediate value theorem to justify that at some time the two cans have the same rate. So if the two cans have the same rate, when we subtract them, d would equal 0. So what I'm going to be looking for in this phrase right here is a place where d of t is negative and a place where d of t is positive, and then the intermediate value theorem will have to mean there's a 0 someplace, unless the function's not continuous, and then maybe that's something we'll mention. So my first step is I think I need to find this m prime, and I know this is the calculator section, but this derivative actually is pretty easy to take. So I think I'm going to say m prime of t is equal to, I have the constant multiple rule, 9t squared minus 60t plus 330. If I was going to do more of this by hand, I could do some factoring, but I don't think it's worth our effort. So I've already put that equation in my calculator. And so now what I need to do is figure out a place where d of t is negative and d of t is positive. So I'm trying to think of the best way to do that, and it occurs to me that what I'll do, I'm just going to write an equation that subtracts, that does that math. So I'm going to take my function that I just did, which I have stored in y3, minus the function they gave me, which I have stored in y1. So now I've basically written y4 equals y3 minus y1, because in y3 I have this, and y1 I have s prime of t. So now I'm going to turn off all the other functions. And maybe I could have come up with the answer quicker by just doing some quick analysis, but this is the thought I had, so I didn't want to waste a lot of time judging the different ideas. Okay, so now I'm just going to graph it, and we're going from 0 to 60, so let's adjust our window. So -5, I'll say, up to 70. I'm going to leave the y's as -10 to 10, because I care about 0, and 0's in that range. Okay, so I found a 0 because the graph shows me something that looks roughly, like this. So I've got a 0 in there. And they're not asking me to find the 0, I don't think. Apply the intermediate value theorem to justify that there is a place. Okay. So what I know is, what information do they want me to say? I guess I would say, since dt is less than 0 for time from 0 to, I don't know, finding the 0 seems like it's kind of silly, because now why don't they just ask me? I guess they want me to explain the mean value theorem. Right down 60, I guess. Okay. So at about 11.8, so from 0 to 11.8166, and d of t is greater than 0 for time between 11.8166 and 60, and dt is continuous, because if it's not continuous, then you could jump right over the axis and never touch it. Since the intermediate value theorem guarantees that m prime of t equals s prime of t. Well, that's maybe not really the way I want to say it. Guarantees that d of t equals 0, I guess. At least once. Okay, so the only thing I don't like about how we answered this is we were very specific about the 11.8166. So essentially we found the 0. So maybe they just want us to say for a period of time we can show that d is negative and then later on it's positive without finding the specific. But either way, I don't see how they can not give us credit for this. Okay, 14-minute video. That's too long. Let me quickly pull up the answers and see how we did. Alright. Part A, 171.813. Alright, so we got 3 points. One for the limits, so they're saying 0 to 60, one for the integrand, and then one for the answer. Part B, 2.863 millimeters per day. Alright. Part C, 602.218. Did I have too many ones in there? Uh-oh. Either I was careless with my math or I've made a small error. but there's a unfortunate, it looks like I probably am not going to get this point for the answer because it's not exact, which I'm okay with. It's fine. So d of 0 is negative, and d of 60 is positive. Okay, so that's what I'm saying. They didn't get as specific as I did. Because d is continuous, the intermediate value theorem implies that there's a time at which d of t has to be 0, which is when the heights are the same. And I guess I didn't connect it back to that means the heights are the same, or changing at the same, but it's all fairly well implied. So let's see. Alright, so I may not get that many points here. I may not get this point because they specifically apparently want us to consider 0 to 60, which I did. I just did it a much different way. Anyway, so there you go. I don't have the stats on how well people did because this is the Form B, so none of the video will contain any of that. Okay, video 2 next.